Thank you, Mark. Hi, so again, welcome to SwissTex, and thanks for coming, and thanks for inviting me to speak here. So I'm from Microsoft. I've been here for about 3.5 years in Zurich, and as Mark said, we purchased a Swiss company, and the goal is to basically scale it up so that it can support Microsoft customers across the world, and I'll be talking about how we do that. So the talk today, I've divided into 3 sections. First about developing scalable text analytic solutions. Second one will be about the work we're doing to integrate deep learning into these. And then at the very end, something slightly different, and I think Mark kind of touched a little bit on that, what might come. I'm going to go pretty quickly today because there's 3 parts, and I want to try to get everyone done. So just real quickly, I'm part of business applications platform and intelligence team or group at Microsoft, and specifically working with a product called Microsoft Social Engagement. A lot of that development work is actually done here in Zurich, in Wollishofen. We also have teams in Czechoslovakia and the US and in Copenhagen, so quite diverse locations, but we all work together to develop this product. We use many different, so I don't want this to be seen like an infomercial, but we do use a lot of Microsoft technology, so I'll be mentioning the products that we use. There are other cloud vendors out there, so they probably have similar tools you can use, and the idea is to more get you thinking into the cloud and then actually having to use Microsoft products, but I will talk about what we do with them. So we use stuff like Azure Blob Storage, Event Hub, Stream Analytics. We do have 10,000 plus active customers using these tools on a daily basis. Our data that we are analyzing is the live Firehose stream, from the different social channels. So anything from news media to RSS feeds from your own pages to Twitter and all these types of different sources. For many different languages too. So this is just kind of like what the product would look like. It's a SaaS, it's a cloud product. So that basically you go in through the browser and you will see whatever topic you're following, we will be acquiring posts and being able to track these things in real time. We can also do so this is just showing the sentiment across the world, and you can kind of drill in and understand more from each region. So what are the types of text analytics we do? Sentiment analysis is something that's been talked a lot about today. It's something we do. We do also intentions analysis, where you're trying to understand what is the intent of the author. So are they looking to complain? Are they looking for information? Do they need support? Or are they actually looking to purchase or book or reserve something? Event detection, using stuff like space-time models to look for anomalies in bursts, in the number of tweets that are happening within a little geographic region, let's say, and that'll allow our customers to understand if there is a situation going on, either to address it or to actually benefit from it, from pushing some marketing content that would relate to that event. Key influencers, understand who are the people that I need to be up to date with and communicate well with, obviously, to get our message across, and topic modeling so that the customer understands on any given time frame what is the gist of the discussion going on around my brand or marketing campaign. So I'll drill in on the sentiment service specifically because that's familiar to many of us, and I'll talk about how that is developed and how that can then scale out to become a service that can support, as I said, many thousands of customers in real time. So we use a product called Azure Machine Learning. Again, it's a big part of the Azure cloud. And we train it the same way that I've heard other people mention earlier today. I think Martin Yagi's team used that when they won the Scalable competition last year. So it's basically using distance supervision with emoticons as the labels. And it supports 18 languages, and we start with around 500 million posts that are unlabeled. And then we add in, for those languages where we actually have native sentiment lexicons that are written by humans or developed by humans, we add those in for additional training. And then emoticon lexicon, and this is all built with Python, SQL, and Val Palo Rabbit. Valpal Wabbit is a very, very performant, not specifically for text, but works very well with text, machine learning toolkit. And it started at Yahoo Research, but is now really under Microsoft Research, and but is an open source product and is available on GitHub. So if you're interested, look into it. It's actually been worked very well on many Kaggle competitions also. And then we use the AML retraining API, and I'll talk about how we do that. So why are we using Azure Machine Learning? So there are many benefits. One is obviously that I don't have to set up my own computers and install the software that I need to build these models with. I don't need to worry about installing Python or some packages I might need to add that are specific to what I'm doing. But most of it comes out of the box as part of this web interface that you can access. So NLTK, scikit-learn, R, all these types of things are already installed. And it allows you to do a lot of this quickly through a drag and drop, but then you can do, like in a Python module, you go in and write your own Python code. But the main thing is that once I, as the data scientist, have developed the models and tested and evaluated, and I feel happy about the quality that it's getting, it's very easy for me to operationalize this. I don't need to go to the IT department and ask them to install software packages and to move my model over there. And I used to work at Oracle, and we'd have customers come to us and say it took them sometimes months to move a model from actual development into production. Now I'll show it's as easy as a click of a button. Yeah, so operationalizing this model, but then also where you can manage it and track it, so you can actually see how many hits you're getting, what is the latency, and as a data scientist, follow this in real time. So Azure Machine Learning helps us with a big part of it here, or the cloud machine learning tools. So it helps us with the modeling stuff, the data acquisition, there's many input data sources, and the deployment of this. So back to why do we use distant supervision? Well, as Mark said earlier, even your gold data is not always that great. It does cost money to get very large volumes of labeled posts, and it's often time consuming. And when you want to get large volumes of data across many languages, for this to scale, you have to think about other alternatives. We do have access to vast amounts of unlabeled data. It also, when you have large amounts that go across many domains and contexts, you have less chance of overfitting your model. And we can also scale to new languages. So if a customer says we're interested in this language, it's actually or it's much faster for us to scale to those new languages rather than looking for somebody who speaks that language well, hire them, and have them start labeling posts. So here's just an example of what this looks like. So this is just a raw text, also known as the best manager ever, happy face, happy face, happy face, and they'll link to their Twitter handle probably. And then basically it goes through some pre-processing. We strip out the links and so on. We take out the emoticons that actually indicated the positive label, and then we add the language handle in front so we don't get cross-language features. And then we use that as an input to the learning. And there's the second one, the negative. So these are kind of like showing that we hope that when you look at a big volume, we find that best is more linked to the positive, and that struggle, in this case, is more linked to the negative. So here's an example of what this would look like in machine learning, in Azure Machine Learning. So again, as I said, it's a drag and drop interface. So here we pass in the large amount of social media posts into the Valpal Wabbit machine training, or the learning module. And then output from that is that node, and that's the model that was trained from the distant supervision. Then we pass it into a second phase where we also add in the native lexicons, and then it takes that original model and adds those to them. And then finally we add the emoticon lexicon at the end. And the output, we have basically a baseline model. So just to look at some of the top features, you can then look at what the model is finding. And this is just using a bag of words model. So here's some of the top most positive. No problem, oh my God, Justin. No prob, welcome, can't wait. So we can then look at some significant or a little bit odd ones. So HAWT, that's probably not something, or that's definitely not something we would not see in a humanly written sentiment lexicon. So that means having a wonderful time. Fav, should def, so your recall really grows with doing this kind of learning, right? Brill, for show, crying, I wouldn't have used myself. And the last one there, I actually had to ask my 14, 15-year-old daughter, why is it so negative? And apparently it means die in a mosh pit. So you'd write something like, why don't you Diane? Apparently. That's where you're very negative. But it does have, it's not like it's, okay, everything is great, we can just, use this and we're done. It does need some refinements. So a lot of kids tweet like no school and a thumbs up when it's bad weather. No class, for example, that's also the same thing, like we don't have class today. So in our case, that would obviously, if somebody flew with an airline and they said that the people that worked at the airline had no class, we would want to see that as negative. So you definitely need to revisit and look at what the model is finding, and then fine-tune these things. Now, where are, I thought was very interesting, why that was seen as negative. And that's because the way people are using it very often, when I looked at the details, is they're saying, where are you? And I'm so sorry, and I miss you, and stuff like that. So here's just a picture showing basically the how AML, or what AML has included. So we can see a lot of the different machine learning algorithms. We can see the data sources, the data preparation tools we have, and then basically, a common type of flow where you go from the import data, the pre-process, you build, you split, and you evaluate and then score it. And what I really want to focus on here is the last red circle there, which is basically the deployment. So how do we take this model that we've created that we're very happy with, and make it actually be able to support thousands of customers across the globe on servers where it can be running and actually make sure that we have the uptime or the SLA that we want to our customers. Okay, so this one there. Oh, sorry. Okay, this is where I'm going to show how this is done. So here, okay, so let's see if we can increase the size of this. Okay, so basically the graphics seem to be a little bit poor here, but basically this is the experiment, this is my scoring experiment, and now I want to deploy this, and I can go down here to the bottom and basically say deploy this as a web service. And it'll start, it'll bring up the next page here and ask me which subscription I want to use. Just a minute if it's got enough internet here. Wait a sec. So then we will just pick a certain plan, a payment plan that we have, and there's free plans so you can start using this and test it out. And then you say basically go ahead and deploy it. And then it'll bring up web services in the cloud so that you can then start scoring with them. And it'll have the, not sure why it's taking a while here. See if the network is up. Okay, let's get back to that one. I'll keep going here in a sec. Okay, I'll bring you guys back to that one in a sec. So let's see, okay, so my next point is that in real estate, location is everything, but in text analytics, context is everything. So even if you have a really good baseline model, it just doesn't matter if you don't know who is going to be using this model. So here, for example, it's all in the eye of the beholder. If you see this tweet, EasyJet or Lufthansa, I prefer KLM, it depends on who is reading this, if you think this is positive or negative. If this was written on the Facebook page of KLM, for example, they would probably interpret this as rather positive, but the other two would say that it's neutral to negative. So how do you make this service so that you can, so that it adapts easily to the customer specific context? So we do this through adaptive learning, and basically our customers start by using our baseline model, But as they curate posts within the applications, we make it very easy for them to give us feedback. You don't want to, I mean, the easier you make it for your customer to give you feedback, the more likely they're going to do it. So they can curate sentiment within the application as they use it. And then customer models are automatically trained in the background. So we will just see that the customer has made updates to these texts, and we will then pass that on, retrain the model, and then update the scoring service in the background for them, and it'll score with that going forward. So here's just an example. Let's say on the bottom one there, the happy face shows that this was seen as positive. We do a continuous scale -1 to 1, but in the application we show positive, negative, neutral. And here it'll say something like, I'll be there, and something else, and it's a positive. So the customer can then just underneath, or click on the happy face and say, I want to change that to neutral, for example, because that's how I see it. So you make it very easy for them. And then we'll see in the training web service here, it just starts with a baseline model. We add in the customer process data, and then out comes the result of this web service is basically a model. You take that model and you patch the scoring web service that you're using for this customer right here, and then you will basically, from then on, it'll take 10 or 20 seconds, it'll have to bring down all the existing services that are running, and it'll take them down, it'll load up the new model in memory, and then it'll be scoring off of the new model. So when you consume these scoring services, there's two different APIs. There's a request response, which is basically a synchronous call. So you can pass 1 to a few hundred, I think, of documents. Basically, it's supposed to be something that runs within tens of seconds. And that's the one we use all the time. So every single post that comes in for a given customer, we feed it off, or shoot it off right away to this scoring service, and so that they don't have to wait. Because some of our customers use this in a customer service scenario where if somebody tweets something negative about a product they bought or a trip they just took, they want to be able to respond to them in real time. So that latency is about 100 milliseconds for us to go ahead and score against that. The batch execution is if you're going to do tens of thousands or hundreds of thousands of posts. And these are all REST interfaces, so any developers or almost any developers know how to interact with these interfaces. So the RS service specifically, the request response, it scales automatically up to 200 concurrent calls. So right off the bat, it'll upload about 20 models in memory, so you can run it at 20, but then as you start using it more, if you start getting close to the 20 concurrent calls, it'll automatically scale up to 200. If you need more than that, then you can easily add additional endpoints and up to 10,000 endpoints per web service. So basically how you need to use this service, how many calls you get from your customer, you should have no problem scaling up. So here just using 5 endpoints, if the average time is 50 milliseconds for each, you can get 20,000 requests per second. So it's really nice, I mean, to go to our IT department and for me to explain and what I need them to do would take, probably at least weeks, if not a month or so, for them to get this into production. And I can just right now go ahead and at a click of the button, it's there, and I can tell our developers, here's the API request URI, and here's the API key, and this is the format you should send the data to it, and this is the type of format the data you'll get back, like in the sentiment, the score, and then we're done. This is kind of showing like just a helper cheat sheet when you're going to use these scoring services or the predictive services, depending on if your data is in streaming fashion, what are the type of tools you can use, or building blocks in Azure. They basically help you do the load balancing and putting into queues and so on, so that you don't have to build these things yourself. If you're going to do it in a batch service, how would you do it with data on-prem, and so, etc. Okay, so that's that for that. I hope that thing has come up. Okay, so here it's basically asking me which service do I want to use, what price plan. So I can say I want to use the free one, and then we go ahead and deploy it. Oh, sorry. Let me escape the... Bring that one up there. Okay, so now it's processing it. We should see it up here in a second. Okay, let's get back to that one too. and I'll talk about what we're doing with deep learning in the meantime. Okay, so first, just to do an overview, and I think we've talked a little bit about this, Mark touched on this morning, and this is a slide that's a couple years old, but I think it still works well. Basically, this is from Stanford. I found it on their website, and it's talking about what do we achieved in text analytics, state of the art today. There's some solved tasks there: spam detection, part of speech tagging, NER. There's some things that we're doing really well at, and machine translation, I think it's bumping it up to the solved tasks. Probably not solved yet because it's still very difficult, but it's doing much better. When I first moved here 3.5 years ago from the US, my kids would come home with a piece of paper from school. I would first enter everything into Bing Translate or Google Translate, and I would understand that it's something about a plant, it's something about this Thursday, and it's something going to happen at school, but I didn't understand, should I send money because they're going to plant something at school, or should I have my kid bring a pot because he's going to plant something at school? So it was almost more frustrating than not, so trying to learn German is something that I should be doing more. But now with the translation tools that we have, I can get those things and I can not only understand the gist of it, but I can actually start to understand the details much better. So I personally, I think that's been a real improvement lately. Sentiment analysis, we'll talk about some numbers here. Obviously we're making progress, but definitely not a solved problem yet. Word sense disambiguation. And then we also have the really hard stuff. I think we've had a lot of people, or some tracks talking about chatbots and that type of thing, where you can basically just have a free-flowing dialogue, and that's obviously a long way away. But there have been really significant breakthroughs. So speech recognition, this is Lee Deng at Microsoft, 30% improvement a few years back. Image recognition with the CFAR10, with the handwritten images. So basically going from an accuracy of 77% down to up to 94. With the ImageNet competition, with the dogs and the cats and planes and everything, I think it's 1,000 different images, or is it, and 1 million documents. But anyways, with the very deep, fully convolutional ResNet that Microsoft developed, brought it down to better than humans, from 28% error rate down to 4.5% just in the last 5 years, with the Higgs boson detection at the CERN laboratories, and then with language translation, as I just mentioned. So what are the benefits for us that are kind of more practitioners? Maybe not all of us are in research, but how can we get our hands on this? Well, the good thing is there's a lot of software available to us now. We don't have to go into Python and start writing NumPy and rewriting how to build a network ourselves. Now it's at a higher level API, so that we can just say, I want to do a convolutional neural network. I want to have this many, I want this depth, and I want to use this many layers, that type of thing. So we can actually start using this in our real applications more easily. There are many, or there are, I'd say, maybe 5 or so big ones. Microsoft's version is called the Cognitive Toolkit, and it's been open source for a few years now, I believe. It's on GitHub, and this is what I use in our GPU servers, or farms. It has Python interface, which is the most important for my sake. So with these improvements that we talked about, has come more requirement, obviously, on computing power. Training still does require GPUs. Scoring is possible that you can do on a CPU. But yes, so you do need access to GPUs to really do this learning. It could be on a single machine, on a single VM. It could be that you need a big cluster to be able to make this to scale across several VMs or several nodes. So if you do need your own VM, you can, in a cloud solution, you can just go ahead and provision one in minutes. So you can basically choose which operating system you want. It comes pre-installed with several of the tools that you would likely need within machine learning and data science. So if you prefer R, there's R. If you like Python, there's that. There's Jupyter Notebooks. And it also comes with a lot of the machine learning toolkits. So CNDK and ValPal Lab I already mentioned. XGBoost has also been really big in Kaggle competitions. And then you have MXNet, which is another deep learning tool. So yes, it's really nice that you don't have to spend too much time setting up your machine. Rather, spend your time actually trying to find the results that you're looking for. Talk about a little bit of the stuff we've been working on. So again, these are main architectures. So the convolutional neural networks, basically you start with an embedding layer. You have to kind of work out how many and what size your convolutional layer should be. And then you do a max pooling, and then you can or cannot use another intermediary connected dense layer, and then basically your dense output layer. And then obviously recurrent neural networks are big in sequence and text to understand the order of the words, but that also can be interpreted by the convolutional neural networks. So these are the two main architectures or techniques that people use. But there's many in between. You can also go from a neural network and then do convolutions. So there's hybrid versions of these things and vice versa. But not so fast. As many have read and seen, these things, even though they do produce really good results, they do have some, let's say, naive mistakes or deficiencies. So it's been shown that if you take an image that is very clearly, or the model is very good at predicting the class, you can actually find a very small amount of noise or perturbations to this data, such that you can trick the model to think it's something totally different at very high probability. So, the way they do this is basically look at the gradient of the model that was trained, and they can see, okay, if I change the error, the noise just in this little fashion, then it's going to start leaning towards this other class. And then if I keep going back and forth a few times, eventually I'll find an image that is very difficult, or that the scoring model will completely incorrectly classify. But to a human, it's no difference, right? So the image on the right is basically the two images on the left put together. And we see that that's still a panda, but the model sees it as very clearly something different. So this is kind of worrisome in a way when you think about self-driving cars that read road signs and stuff like that, and where they could see a speed limit sign and it's really a yield sign or something like that. So these things a little bit worrisome in a sense. Okay, so back to the sentiment classification. So here's just kind of comparing of what a linear regression model can do, or the one that we're using. So here it's the bottom one is just showing only using distant supervision. And this is looking at, I think, 40 to 50 million English posts. So not just deep learning benefits from large amounts of data, but even linear models can really do improve significantly from having vast amounts of data. I don't know, I'd say it's at about 20th spot or 18th or so in the competition without even seeing the training data. Then if you look at a deep learning network, you get up to about 0.62 or 0.617, at least using the tools I'm doing, using the same distance supervision data. Now you're around 10th, 11th spot on this. And again, just to be clear, these competitions, this is scored against the 2013 evaluation data. And that column on the left is, you can see that it's much higher than the other years, because that's the data that most of these entries have seen the most data for. So many of these entries have actually used a lot of this data, the training data that was available to train those models. But anyway, so then if we just add in the lexicons that we have from the native, the English lexicon, we get up to 0.626. And now we're around 7th spot or so. And then finally, and that's before seeing any of the training data that's available as part of this competition. So that's pretty neat that out of the box, a customer could use the model and actually get nice results without even having it trained for their domain. So this model is obviously trained using social media posts, but it's never seen the training data that was specifically done for this domain. And we try to keep it as broad and domains as possible, because we have customers everything from football teams like Real Madrid to travel companies and so on. So we don't want to focus too much on a given domain. Another common data set that's used to evaluate text models is the IMDb movie reviews. And this one's a little bit more difficult because this is not social media posts. These are longer, and they are talking about a subject that's just slightly off. So here we can see that the model doesn't do so well off the bat. 26 is putting it, there's another one in there that's 32 using LDA, so it's in the bottom of the pack. But again, it's all those other, all those entries over there have seen the training data. This is just using distance supervision again. Then we add in the training data, and we're now at 16.4, and we're getting closer here to some of these other ones that are, let's say, in 20th spot or so on this. This is just taken from a paper that was released recently for topic RNN and adversarial training. That just kind of summarizes the different scores that you can achieve. But then just using a linear regression model purely on the movie reviews data, training data, you get to 9.4. So yes, it's not as good as these other, I think the top 4 or so are in this 8% error rate and lower, but it's still beating out other LSTMs and such. So again, back to the point I think I've heard many times today is that even though deep learning is promising, it's not necessarily the only thing going on right now. And for training on 50 million posts with the VW linear regression model, it takes about 1 minute. Training it on a deep learning GPU takes about 5 hours. So it's a big, big difference in time there. But what can we take away from this? Well, this is very context specific, not only the length of it, the words and stuff like that, but also here, one thing that stuck out as I looked at it is that when people use words like tears and crying and stuff like that for a movie, it often is highly rated when in social media posts, and the way we see it, it's actually received a low sentiment score, and that was a big issue. It takes more text to really retrain the model that way. So some things we're looking into, context as a separate feature to the words. So not just the order of the words, but also taking a context in addition to the order of the words. So if you could know that the gist of this text that we're trying to learn from here is about movies, then you might look at the ordering of the words differently than if it's a product review or so. So there are different things going on right now with the contextual LSTMs, topic RNN, and then there's also character engrams, which is popular, mostly for language translation. Adversarial training is very interesting. It's basically what I talked about with that image, where you try to fool the network with a small change, and then you learn you try to train the model to be more robust against these perturbations. And then there's obviously additional things. There's an interesting paper recently by OpenAI about evolutionary learning for text, and how that has a potential of not only speeding up the training and the learning, but actually improving results. Okay, so the last part of the talk, this is just the last 5 minutes here, and it's about the America's Cup. So let me set the stage here. Since I'm in Switzerland, at the time I didn't know I was going to move to Switzerland, so I was working for the American team, and basically my boss was the owner of the American team, so I couldn't really refuse, and he's very wealthy, so of course you help out. Okay, so Lingy had won twice previously. Our CEO is very passionate, or my previous CEO is very passionate about sailing, has done it since he was in his teens, but had lost the America's Cup twice. And he doesn't like losing. He always had this motto, it's not enough that I win, everybody else must lose. And that's what we all loved at Oracle, but now I'm not with them anymore. So anyways, so this race ended up being basically battle of billionaires. And usually what happens is there's a challenger and a defender. The defender, Lingy, they would kind of sit down and work out the terms of the next competition and come up with a one design boat so that everybody can kind of build that, and then the best sailing team wins. These guys could not agree on a single thing the day of the week. So everything went to court, and basically it ended up being that what happens in that case, if you can't agree, they basically have almost no limitations. So it was just that it cannot be longer than 90 feet long, and I think 90 feet wide. And then it's basically go do your best. So I didn't know I wasn't really following the America's Cup, even though I kind of like sailing. I'm an amateur sailor. But basically this is the boat they lost in the previous challenge. And they called us up, our team at Oracle, and the advanced analytics team, and said, look, we're wondering if you guys can take a look at some data and see if you can get some performance improving information out of it. And everything was anonymized, and they just told us which attribute was the target, what we were looking to understand. And we took a few days and looked at it, and we sent back some information, and we had a meeting, and they thought, wow, this is, okay, so something clicked, they liked it. And it was, I think one was, for example, we could tell who was at the helm when the boat was not performing well. And they said these were certain training sessions when they knew that the skipper holding the steering wheel was making a little bit too big adjustments. So it was finding that the angle of the rudder, how it fluctuated, was slowing the boat down, that type of thing. So then they said, okay, then they told us this is the old data. We want you to look at the real new data. And I didn't know that they had launched a new boat, but basically they built a monster, and they then showed us the data for this boat. And this thing is massive. It's really cool. It's super fast. I think it was faster than any boat in the US Navy at the time. It goes 3 times the speed of the wind. Going downwind, it has a 30-degree apparent wind angle, meaning it's basically going towards the wind when it's going downwind. It's that fast. Okay, so the data here, and the reason why they really wanted to get machine learning into this is because normally they have 2 boats, at least 2 boats, and they'll race them against each other for, let's say, an hour, and they'll tweak something on one of them. They'll tune the rigging, and they'll see how it performs against the other boat. And they'll always be comparing like that. But in this case, they only could afford, even though they had a lot of money, they only built 1 boat. And the question was, when they made changes overnight, how did that affect sailing the next day? Or even if they tuned something while they were running, how would they know how well it did or not? Because the conditions are continuously changing. The mast is 200 feet tall, so the wind is changing, the humidity is changing. There's just waves and currents and everything. So the question was, if we send you guys the data, can you try to understand where we get rid of the environmental factors and see how well this is doing? And they had a lot of data. And this is 7 years ago, so big data today is a lot different. But 7 years ago, this was big data for us. So 1 hour of sailing was 100 million data points. They would be sailing for hours, and then they would upload it to a data center in Austin, which is basically where we had our cloud back then. And we would do some work on it for a few days and then try to get the results back. So VMG is what the target was. That means velocity made good. It's basically when you're going towards a buoy upwind, you can either go straight at it really slowly if you're sailing, or you can go sideways towards it. And the more sideways you go, the faster you go, but it's the vector that matters. And that's what VMG is. And they would measure, a lot of things. They had 250 sensors, lots of different things that they could measure on this boat. So I was working on this, and they had 2 masts at the time, and this is about November, and the race is in February the next year, in 2010. I was working on this in 2009, and I was working on their 2nd mast, and the question was, at what mast rotation should they use at different conditions, so different wind conditions and so on. And they had a 1st mast, and then the 2nd one was the improved version. And we had been looking at the rotation so that the sail gives the best shape and so on. And this mast is about like this wide. This is not a round mast. It's shaped like a wing, and it affects the shape of the sail. So I've been working on this for several days. And right as I'm about to say, I got the good results, I'm going to send it to them, I see on ESPN that the mast broke. A $10 million mast just snapped at the base. And this was the good mast. So we're only 3 months out now before the competition, and I'm thinking, this is over. we're done. You know, it was a fun thing though. But no, secretly they had a wing being built by I believe a subcontractor to Boeing. So this is a fixed wing. This is no longer a soft sail. It's hard to see in the graphics here, but you can see here. It's more like a wing on an airplane. And this is actually here you can see an Airbus A380. So it's 80% larger than the wing on an A380. And these are big things, right? And to be honest, I think this is what won it, not my data mining. This thing was just incredibly good at taking advantage of the wind that was there. But here's just a little video kind of recapping the competition.
It's an extraordinary machine. It's certainly a case of extreme engineering.
You can look at something on paper and you can try and visualise what it'll look like in reality, but when you actually stand there and see it in reality, it's amazing.
It blows us away. I mean, everybody comes here, sees it for the first time, and blown away. We're still blown away by it. We see it every day.
Extreme design. Using the most advanced materials and technology to create the fastest sailboat that's ever been built. To race in sailing's premier competition, the America's Cup.
Sorry, did I miss that?
The sailing world has never seen a boat like this.
Long hull of those dimensions hasn't really been built before. Boat that's literally as wide as long and on that scale.
Over 2 years in the making, hundreds of thousands of man-hours across the country by an international group of the world's best and most dedicated boat builders. Built of carbon fiber to be light and strong, 16,000 square feet of sail, over 2 miles of running rigging. Measurements and calculations are critical. Every detail is important.
It's just an exercise in 1,001 details. Putting it together, it's like baking a big cake. So we've got our head down, working as hard as we can.
In August 2008, BMW Oracle Racing's Trimaran is revealed.
Just pure shock and excitement. It's just awesome what the designers and the builders have produced here.
And now, the test begins.
Everyone just kind of smiled because it really took off.
Sensors all over the boat collect 26,000 data points per second to help the sailing team learn just how far they can push it.
It gives us a whole new insight into how the structure is performing. Can this winch take more load? Can we pump the hydraulics harder? All of these things we can answer for them.
In November 2009, the team takes boat design to the cutting edge with the addition of a huge wing sail. At 190 feet tall, it's larger than the wing on an Airbus 380 jet.
There's just never been a multi-hull this big with a wing. It's unbelievable. I mean, quite literally, you look at it and you can't believe it.
Innovation, skill, dedication, and teamwork add up to extreme performance. And extreme performance is what BMW Oracle Racing will take to the America's Cup.
It's not just the sailing team, it's the shore team, it's the design team, it's the legal team. I'm very proud of everybody involved. The chances of that boat.
Okay, so how did it go? Of course we won. And they haven't lost since. And if you're interested, it's actually ongoing right now. There've been one competition in between in San Francisco. They're doing the Louis Vuitton right now in Bermuda. And Oracle is the defending champion and will be sailing against the winner of the Louis Vuitton here in the next 2 weeks, I think. Thank you very much.
Thanks, Peter. I think we ran a little bit over time, but I thought I'd just let it run because it was so interesting. Anyway, I think we are here for text, so maybe if we can concentrate the questions on text analytics, this boring stuff that we started in the morning.
more fun stuff, of course.
No. So let's take some 2 or 3 questions if there are any urgent questions. You know, text analytics, Microsoft?
Thank you for this really interesting talk. I very much enjoyed the video you just showed. But coming back to the text aspect, I was wondering, you talked about this using distance supervision before for labeling sentiment in unlabeled text. And I was wondering, what is your experience with respect to recall and precision, especially for negative tweets? Because my experience, I've used that before for Arabic, and especially for Arabic, it seems to be that detecting the negative class using distance supervision is really, really hard. And we haven't had a clear answer why. We suspect that it's the way they use it in context, that it can be quite a lot of it can be ironic. So I was wondering, I guess you looked into English primarily, and is it a problem for English as well?
Yes, no, we do evaluate for each language that we support, and Arabic is actually one of them. I wouldn't say it's one of our stronger languages, because it is, you know, first of all, there's less data that we have access. We also have, let's say, fewer customers that are really pushing it and that help us understand it well. But we do support it, and I wouldn't say that I know specifically that our model is specifically weak for negative for Arabic. I haven't looked at that. We generally look at the total F-score. I think our Arabic is actually on par with many of our Eastern European languages, but I'd have to look into that in detail. I can let you know more about those numbers.
One more question. Yeah, Manfred?
What about privacy on Azure ML?
Privacy on Azure ML.
Is my data replicated in the US?
No, so you can choose which data center you want to upload your data to.
Of course.
Yes.
But is it replicated in the US?
I don't believe so, no. No, sorry, I mean, I can get back to you specifically on this, but no, we have data centers where both the computation and such happens in Europe, in Middle East, or in Asia, and in North America. You can use encryption at rest also, where when you put the data there, but then when I think they're working on the encryption when it's moving through AML, but it's never stored as part of AML to do the learning, if that makes sense. So let me I can see if the machine learning actual computation happens in Europe too. But yeah, I can look that up for you.
Okay, so thank you, Peter, once again for being here.
Thank you.
As in the morning, we have this great wine from our winery. I hope you can enjoy it.
Thank you so much.
Yeah.